heard a bit about, quite a bit about COMAG, we heard a bit about perpendicular recording. So Ed, why don't you tell us a little bit about what went on in HP and fill in some of the things that maybe, what do you remember? Do you think there's some interesting stuff in overcoats that you might want to talk about? Just give us a little background on what went on there at HP Media.
Yeah. Okay, so I joined HP Labs late in 1980, and they already had a thin film media recording project going. And I'm not sure exactly when it started, maybe in 79 or thereabouts,
Right.
like that. So it was already underway, and they brought me in, hired me out of graduate school, where I'd done, of all things, liquid helium. Very closely related to magnetic recording. But I knew a lot about vacuum systems, and so they put me to work doing sputtering and replumbing the sputtering systems and stuff like that, and characterizing the media, and developing the cobalt platinum thin film media that we had. And as nearly as I could tell, the reason cobalt platinum was chosen was because platinum was expensive and it was HP.
Yes.
But it was good days, and we had the basic structure had a thick chromium base layer to normalize the plated disc,
Right.
and then the cobalt platinum layer, and then a chromium layer on top of that, supposedly to seal it and protect it from then the sputtered cobalt oxide wear layer
So
that we put on it.
So everything underneath that was plated, or were there some?
So it was all sputtered.
It was all sputtered.
I mean, the substrate
Substrate was plated.
was nickel plated and
nickel-plated.
polished.
Okay.
And
Everything else is
I
plated.
think those were made at HP's disk memory division up in Boise, and sent down to us, and then we had to clean them, and we developed techniques for making measuring the particle count on them and cleaning them and that sort of stuff. So we did a lot of work on that. I got interested in 83 or 84 in media noise because I was real frustrated. As a new guy just out of graduate school, you look at the literature, and what I saw when people talked about media noise was that everybody defined it differently, and usually in contradictory ways. So nothing made sense. And so I started studying media noise and doing a lot of experiments to measure the media noise. And there was a guy at HP Labs in a department adjacent, related to ours. Dick Baugh was his name. And he understood a lot about the electronics and the error rate stuff and timing jitter of the pulses. And between us, we figured out that one of the main effects in media noise is that as you measure media noise by writing some transitions and then averaging the noise power around the circumference of the disk over a period of time. And the problem is that the noise is not statistically stationary, in that the transitions are noisier than the DC regions between the transitions. And so you get this, as you increase the recording density, bring the transitions closer together, you get a linear increase in the noise power that you measure. And a lot of people thought that was real, that there was something real there. And Dick and I figured out, he figured it out, and then between us we figured out ways to prove that that was just an artifact of the measurement technique.
Okay. Yep.
That and then how to figure out what is actually going on, and pull out what is the actual transition contribution to the total noise on there. Which,
I think that was in that paper that was published in the HP. There's an HP journal.
yeah, we did a lot of work on that.
Right.
A lot of work on that. So then, but one of the funniest stories has to do with that sputtered cobalt oxide overcoat that we used, which is reactively sputtered cobalt oxide, and you had to get the process just right. At the time in the early 80s, we liked that a lot because when we did the contact start-stop tests with the old ferrite sliders that had the hand-wound wires for the transducer, we basically could not cause a crash. we could run those things for 100,000 start-stops. I think Chuck Morehouse ran one once for a month for 1 million start-stops or something like that, and it never failed. And then he took some of the discs out and did some kind of electron microprobe X-ray measurements to measure how deep the wear track is, because you could see the wear track on this beautiful blue disc. You could see the wear track, and it turned out to be 10 angstroms deep.
Wow, that wasn't much then.
After 100,000 start-stops or something
Wow.
like that. It was just amazing. So it was really great stuff. And
Yeah.
Disc Memory Division was all excited because they're going to have the best wear performance of anybody in the world.
But then,
But and they were ready to go to production with the first product when one of the engineers in the group sneezed on a disc one day, and he said, "Oops." And so he quickly got some DI water and washed off the disc, and blew air on it and washed. Then he put it under a microscope to take a look and make sure that he'd gotten it properly cleaned like this. And what he saw was these little star-shaped things popping up on the surface of the disc. And after some more investigation, he realized it was delaminating.
ouch, that's not good.
It just popping loose.
Yes.
And what we figured out eventually after there was some really nice science that went into measuring the galvanic potential and so on. We found out that what we'd created with a cobalt platinum recording layer and a cobalt oxide wear layer separated by chromium, we created a battery that had like 50 millivolts or something of potential. And so it didn't require actual liquid water on the surface. Just as soon as the humidity is high enough that the surface layer of adsorbed water is more than about 3 molecules thick, that it becomes liquid enough to go down through pores in the layers and make an electrical connection to the layer, and it wouldn't have been so bad except that the cobalt platinum recording layer was the cathode, so that dissolved.
So that didn't work too well.
That didn't work too well. It actually set back the program for a year.
And this was in Boise, right?
No, we discovered this at HP Labs.
At HP Labs, okay.
At
So that
HP
was-
Labs.
that
I
was-
forget the guy's name. The sneezer, right? No, it wasn't Daryl. It was somebody in Ari Kurtzig's department, which is the associated department. But so that set the program back, and it would have been discovered earlier up at Disc Memory Division in Boise, because they were doing environmental tests on the discs, where they were putting them in, four-corner testing with humidity and temperature like that. Only they had skipped the environmental tests because the drive was supposed to ship in 3 months, and the tests would take 6 months. So we're not going to do the tests.
Famous last words.
Yeah, and then our guy sneezed on the disc and discovered.
So then you had to reset?
They reset, and I don't know. Maybe they stole your carbon overcoat.
Yeah.
But I mean,
HP was our good customer actually. Ship enough this for them at the time.
yeah. So
It never
eventually,
shipped
yeah.
with the cobalt oxide. The drive never shipped.
Never shipped with the cobalt oxide,
Oh,
which
that's
is a good thing. It
probably a
would have
good
been
thing.
shipped right back.
Actually, cobalt oxide was also there's a cobalt oxide by Polydisc back in the 70s. Xerox PARC tried to use cobalt oxide, but they use a frame torch, frame the cobalt phosphide basic and then a frame oxidizing it.
Oh, wow.
We tried it too,
Huh.
but I don't know. It was kind of weird also.
Well, Comag had its own history of...
No, it was a
Yeah,
PARC, not
yeah.
the Xerox.
Xerox PARC, yeah.
Comag,
Yeah.
That was back in the 70s.
And could you the paper that was published by HP in that special journal described the commercial disc as having the carbon overcoat.
Mm-hmm. Which is the one that shipped.
But
right.
it's silent about a lubricant. Did it have a lubricant?
Yes, I'm sure it did. 'Cause I remember discussions about whether you could ship the carbon overcoat dry or whether you needed a lubricant. And by that time they knew that even the ferrite heads didn't work very well on an unlubricated carbon surface. So they had to figure out how to lubricate it as well. And that work was not done at the labs, it was done up at Disc Memory Division.
Do you remember what the lubricants were?
I don't know.
Okay.
Yeah, because we try to, somebody mentioned that, forming AM 2001.
Yeah.
We tried that one work. I mean, it worked. It's better than no deal, right? But
Yeah.
it does last 20,000 times. So we have to keep looking for it.
We actually had, Tom Gartner sent a whole mess of emails that he was digging up stuff about various
Yeah, but-
history things he sent around to the group here, that's what you're
Right.
referring to, yeah.
Yeah,